All right, let's talk about software engineering, finally. All right, so again, we're concerned with large-scale projects, and that they become complex very quickly, right? And it's mostly because you're dealing with other folks, right? If it was just you and a couple of buddies, right? So software engineering skills would just be an overkill, right? Only when you start having 10, 20, 30, hundreds of folks working on the same project is that you need to start applying software engineering principles. And these engineering principles go across multiple industries, not only software. We're specifically interested in applying them in software development, right? And they are very common engineering principles that you find in other industries, such as applying the scientific method and technical knowledge, designing. Instead of before you start building anything, let's design this. Let's make a prototype, right? Let's draw it on a piece of paper, right? See if it's feasible, right? Let's think about how hard this is, right? And let's plan this. We don't have infinite amounts of money and resources and time. We need to prioritize and see what it is that we should focus on first, right? Are things that depend on each other? Should we focus on things that are independent of each other first, right? And see how they depend later on, and how is that, do they need to be built in a particular sequence? First build this and then build that, right? Because they have dependencies between them. So planning certainly is important. Also managing, we need folks that are good at keeping track of folks that and asking on how they are and their progress, and then informing all the stakeholders of what is the progress of the project, and documenting, and using all sorts of diagrams for documenting the wireframes of user interfaces, or class diagrams, of sequence diagrams, activity diagrams, so that not for documenting purpose per se, but at least as a communication device, so that we can all agree, even if I know Java and MySQL and JSON, can we all agree, right, that these are the properties, right, that these are the correct data types, right, that this is the correct structure, right? Regardless, even if we are using different frameworks, we can all talk the same language. Yes. Also, how is it that we're going to make sure that this is actually working, that the requirements are actually being met, that we can test in an objective way, know that this is indeed meeting a particular, that this is exactly what we wanted, and also realize that more than half of the entire money that we're going to spend on any particular project most of it is going to be spent after this has been deployed, right? Once you're done and implementing and this goes out the door into production, there's much more to do even afterwards, maintaining this, keeping the lights on, right? So anything that we could do to make our lives easier after the fact that somebody's now using this, it's live, right? There will be money well spent. And the reason projects are hard is that dealing with folks is messy. Dealing with people is messy. We usually underestimate the risks. We overestimate on how our particular skills are being able to deal with complexity. We like to be nice to people. We don't like to say no, and we inadvertently commit to more than we can handle. Right? We have egos. We have self-interest. We're very subjective, right? So we need to compensate for our subjectivity by applying the scientific methods and technology, right, to provide an objective process that we can measure something objectively, right? So just as a historic grounding of how hard projects could be, here's one particular well-known disaster project, and we can look at what went wrong here and try to avoid what we have learned from this. And even though this was a monumental disaster that was very well documented, there are lots of projects that are much smaller that fail, right? And it's a staggering number of projects that will fail, that we know there's just going to be money down the drain, that we'll need lots of rework, lots of re-implementation. But this one in particular was just historically a blunder. So this was an automation of the conveyor belts for delivering luggages in the Denver International Airport. It's a huge project, twice the size of Manhattan. The original assumption that it was going to be done only for United, which was the biggest airline in the airport. Eventually, it ballooned to include the entire airport, and so the project quickly grew to three times of the original size, right? And folks underestimated what it meant to deal with 3 times the size. We humans tend to think in a linear fashion. We think that if it's twice as big, it must be twice as hard. But oftentimes these processes are not linear. Oftentimes they're exponential, right? So things that twice the size doesn't necessarily mean twice the effort. Oftentimes is that it's not 2 to the the exponent is the variable, right? It grows exponentially, right? So yeah, 3 times the size. So there's the scope of that ended up being 20 miles of track, 55 different computers that had to talk to one another, 56 laser arrays, 400 frequency readers that most of them failed. So the first thing that they failed to do, that we tend to do as humans, is to arbitrarily ask for a date by when this is going to be done, right? Or that we arbitrarily put a date out there that we say, oh, we'll be done by this date. There's no way we could possibly know that these dates arbitrarily when we haven't gone through this, especially if we have all sorts of examples that are readily documented that have taken much longer than what we possibly are thinking. For instance, they committed to a 17-month delivery schedule, right? When there were very well documented similar systems that only for testing, they had been spending 24 months just testing, and not implementing, but just testing was only going to be twice as big as what they were already committing to. Most of the buildings were already built, so there was a lot of things like they could not modify, that they were already constrained, that was not in question that they could modify, and they really had no communication whatsoever with these other well-documented similar projects. And even within BAE, there was a lot of miscommunication. The final blunder, they decided to broadcast live when this was going to be available, the first prototype. It was a total disaster. Carts got jammed up. They crashed. They ripped luggages apart. You had wind, clothes strewn to the wind, and all on national TV. And they were working their computers to the limit of their load, 95%. So there was only had a 5% overhead of being able to be wrong, right? It was just a mess. BAE went bankrupt. They overspent $1.3 billion, and the whole system was just thrown away in 2005. Biggest problem is requirements. This is where projects are most vulnerable at the beginning, when we haven't agreed yet on what is it that we are going to build. Right? This is the hardest thing to do. Do we all know what it is that we're building? And that's the hardest thing to do, and that's where we're going to start next time around. I'll leave it here. All right, thank you.